Now we're going to be finding every single part, not just x. And the reason why I want to do that is I want to show you how to do that. Because there will be times when you have to find every single part of a right triangle. Now, for number one here, here's what you do. You know one side, one angle. Now, when you know one angle, here's what I would suggest. First, we know one of the angles, this was 72 degrees. So I can, like, first things first, I can say that 90 minus 72 will equal the second acute angle. So what's 90 minus 72? 18. So I know the second acute angle is going to be equal to 18 degrees. So this guy up here is 18 degrees. So that's almost like a gimme as far as the information goes. You can get that second angle without a problem. Now, one thing that I would say is only use the given information whenever possible. So only use the fact that you have 72, 6, and x right there. Now, I'm going to put a y here because I don't know exactly what that is. And if you know the one angle and the one side, what you're going to end up doing is not only can you find the second angle, but two, set up your sine, your cosine, and your tangent. All right, hold on 1 second here. All right, so set up your sines, your cosine, and tangent for the 72 degree angle. So I want the sine of 72 degrees. That's going to be equal to something. I want the sine, or not the sine, I want the cosine of 72 degrees, which is going to be equal to something. And then the tangent of 72 degrees is going to be equal to something. So we take a look at the angle that we have here, the 72. Now where's the hypotenuse? Which one is it? Is it 6, x, or y? Oh, okay, so I got all three answers. What's the one opposite 90 degrees? X. Here's your 90 degree angle. That's your hypotenuse right there. Now, with 72, now that I have the hypotenuse, the side opposite 72 is what? It's going to be y, so what's the adjacent side? 6. So finding your hypotenuse is going to be the most important thing that we do. It's going to be the longest side, and it's the side opposite 90 degrees. Then you have to figure out your opposite and your hypotenuse. And based on yesterday's quizzes, which you'll get back tomorrow, because I just, if we have time today, I'll pass them back. If not, pass them back tomorrow. You guys did really, really well on picking up that stuff. A few hiccups here, but not that big a deal. First time going through it. Like I said, not that big a deal. Now, with the sine, we're going to end up using SOHCAHTOA. Now, the sine is going to be opposite over hypotenuse. So what's the opposite here? What do we label that as? Y. And the hypotenuse is x. Now, can we use this to solve for x or y? No, we can't use this. They're two unknowns. If I have, this is just one equation. How many unknowns can I have in one equation where I can actually solve the equation and figure out what that unknown is? One. So for any equation, I can only have one unknown. If I have more than one unknown, I can't use it. So I can't use the sine at all. Now the cosine is the adjacent side. What's the adjacent side? 6 over the hypotenuse, which is x. How many unknowns are here? So since there's one unknown, we can solve for x. So I can solve for x in this case. Now for the tangent is opposite. Here, let me move that. Is the opposite side over the adjacent side. What was the opposite side? Y. And the adjacent side is 6. How many unknowns? 1. So there's one unknown. I can solve that for y. So when we're dealing with this, what you're going to want to do is, alright, I figured out that second angle pretty easily, 90 minus the other acute angle. I got 18 degrees. Then you build 3 trig functions. And when you have like one side and one angle, only 2 of the 3 are going to work. So your job is to figure out which 2. Now, we figured them out. We can't use the sine, but we can use the cosine and the tangent. So what I'm going to do is I'm going to, since now the picture's all messed up because we labeled it, and that's fine. Labeling it is just fine. I would recommend labeling it in pencil as opposed to pen. It's just pen shows up a little bit better on the video than pencil does. Now it becomes algebra. Alright, good, no groans or anything like that. Take the first guy. The first one's going to be the cosine of 72 is equal to 6 over x. Let me write that better. The cosine of 72 degrees is equal to 6 over x. Now, the cosine of 72 is one entity. You can't move things. You don't want to multiply anything to the 72 degrees. It's the cosine of 72. 72 stays with the cosine. If we're going to multiply anything, it goes out in front. It never goes, you never do anything with the angle. We're not going to touch that angle at all. Now, how do you solve for x if x is in a denominator? What do we end up having to do? Not even sure that's proper grammar, but Well, just think of an equation where if this was 10 was equal to 6 over x. How am I going to get rid of x in the denominator? I'm dividing by x. So what do? Multiply by x. So here, I'm going to multiply that by x. So I'll get x times the cosine of 72 degrees is equal to 6. And now since I have x times the cosine, how am I going to isolate x all by itself?
I feel better after I watched the next episode. I understand why Obi-Wan was letting himself be captured. I'll explain later. But I feel like I'm not watching a sham anymore.
Obi-Wan always has a plan. Alright, now we just divide. This is how you basically solve this. When x is in the denominator, you're going to multiply by x and then divide by the cosine. Those divide out. X is equal to 6 divided by the cosine of 72 degrees. One thing that I always say is there's a pattern. Every time that you have the variable here, you can change it to x is equal to 6 divided by the cosine. You could basically just switch places with the cosine and the x. It's one of those really nice things. But that's only when the variable is in the denominator. Now, this becomes a calculator problem. And I'm just going to use this guy. Because it's a little bit easier to use. And with this, you go 6 divided by 72, then you have to hit cosine. And then you get x is equal to 19.42. Now, if you don't believe that, you can always use a regular calculator. If you don't believe that, because sometimes you'll see the numbers and you're like, that doesn't really look that great. We want 6 divided by the cosine of 72, and then I want degrees. I want to make sure that my calculator knows it's in degrees. Oh, my calculator's crazy like that. Isn't that the same answer that we got? Alright, so this is the illegal calculator that you can't really use on any tests because it'll do everything for you. It'll factor, it'll do all that stuff. This is a beautiful calculator because all you have to do is know how to type stuff in. That's why you get crazy answers like that. But that's what we end up using there. Now the second part is, now that I know x, I have to figure out what y is. Now, so my tangent of 72 degrees is equal to 6 over y. Actually, it's not equal to 6 over y. Y over 6. So what am I going to multiply by? Multiply both sides by 6. Because 6 is in the denominator. And 6 divided by 6 is just going to leave me with a y. And this is 6 times the tangent of 72 degrees. So again, you're going to find a couple patterns that are going to develop from here. One of the patterns is up here. When your variable's in the denominator, just move your variable to this side, put the cosine or the sine or whatever in here, and you're good to go. If the variable is in the numerator, you're just going to multiply whatever that trig is, that trig ratio is, by whatever the denominator is. So now I have to take 72 and then the tangent. Graphing or scientific calculators, when you can't really just put everything in, you gotta do it like that, and then that times 6, and you get 18.466. So y is equal to 18.466, which is about 18.47, because we usually go to the hundredths at this point. Now that guy was 18, this guy was 72, this guy was 6, the longest side was 19.42, and the other side was 18.47. So we were able to solve this. Now, in order to make sure that this is actually this is an actual triangle, here's how you check. Use your Pythagorean theorem. And this is, I don't want you to do more than just kind of check the values in the calculator just to be sure. Get 6 squared plus 18.47 squared should be equal to 19.42 squared. So again, this becomes a calculator issue, where you just take 6 squared plus 18.47 squared, and you get 377.141. Then if you take, 19.42 and square it, you get 377.136. Now, are these close? Yeah, these are really close to each other. Now, why would they not be exact? Is the exact measurement of the side y 18.47? No, what do we end up doing? We rounded. So a rounded answer is not an exact answer. Same thing with 19.42. That wasn't exact. We rounded that as well. If we used the best available information, like the exact value of x is 6 divided by the cosine of 72. But if you're trying to make something like a frame that's a right triangle, you're not going to go into Home Depot and say, I need a length of board or a length of molding that's 6 divided by the cosine of 72. That doesn't make any sense. You're going to go in and you're going to say, all right, I need something that's about 19.4, almost 19.5 inches long. And then you'll have to do some trimming and things like that. So, that's why we end up actually having to calculate it. We round it up. We get a decent answer. Are these pretty close? Yeah. I mean, the difference is 0.005 between the two of them. So does that tell me that we did this right? Yeah, I think so. I think we did it right. Now, we're going to do a little bit more with this. I wanted to show you how to solve for the whole thing. This worksheet, though, says we're just solving for one side here. Now, basically all you need to do in this case is say, all right, well, I have a 73 here. Where's my hypotenuse? Like for number 2, and I'm just gonna let you just solve for the missing part right now. Now, first off, where's the hypotenuse? Yep. So 6 is my hypotenuse. So if the first thing you do is locate the hypotenuse, if you have it, you're in business. If you have the hypotenuse, you can use a sine or a cosine, because you're not going to use a tangent. The hypotenuse is 6. Now I have to figure out, do I have opposite side or do I have an adjacent side? Yeah, for 73, I have the x here, which is the adjacent side. So I know the adjacent side is equal to x. Now, what if I have the SOHCAHTOA, which is just something to help us figure out which one we got. I have an adjacent and hypotenuse. Which one has the adjacent and hypotenuse? Is it sine, cosine, or tangent? Cosine. So the cosine of the angle, 73 degrees, is equal to the adjacent side, which is x, divided by the hypotenuse, which is 6. So how am I going to get x by itself? I'm dividing x by 6. So what do I do to get rid of that 6? If I'm dividing by it, how do I undo division? Multiplication. So I'm going to multiply both sides by 6. So x is going to be 6 times the cosine of 73 degrees. So I have to do 73 times the cosine. I get an answer, times 6. So x is equal to 1 point. Now it says, the directions say, go to the nearest tenth. Now if I have 1.75, what's the nearest tenth? 1.8. And that's what you're going to end up doing for this entire worksheet, is saying, all right, well, what do I have? Identify your hypotenuse. Now here's your hypotenuse, because it's opposite 90 degrees. Do I have a value at all for the hypotenuse? So if there's no hypotenuse, the only one we can use is the tangent. If you have a hypotenuse, you can use sine or cosine. Oh, sorry. I was looking at the worksheet, not at the video. At the screen. If there's no hypotenuse value, whether it's an x or a number, you can't use it. So sine and cosine are eliminated from our discussion. So I want the tangent of 24 degrees. So I need opposite, which is right here, and I need adjacent, which is right here. So tangent is going to be 6 over 12. Multiply both sides by 12, because I have x divided by 12. I want to get rid of that. Multiply that by 12, that by 12. So 12 times the tangent of 24 degrees is equal to x. .24 times the tangent, or 24, the tangent of 24 is that, times 12, 5.34. So x, if I want to go to the 10th, is 5.3. Alright, so I did show you how to find everything, because now that you have 5.3 there, you could have used a sine, a cosine, or you'd use a cosine here, because you have an adjacent. To find the hypotenuse, you'd have a cosine, and then you can figure out what the other angle is.